This is section 6.2, which is over the law of sines. Here are the objectives. Basically, what we're going to be doing now is we will be solving triangles that are not right triangles. So we will apply the law of sines. And there are different types of triangles in which we can apply the law of sines. But we'll find something called the ambiguous case, which kind of complicates things, but I will show you some ways to ease that issue. So the first thing I want to talk about are oblique triangles. And oblique triangles are triangles that do not contain a right angle. So there are two different types of oblique triangles. Basically, one that has an obtuse angle, like this one here, or one where they are all acute angles. For an oblique triangle, we will be given the length of a side and some other two parts of the triangle. And there are four cases that we will see. The four cases are shown here. We can either use the law of sines or the law of cosines. And in this lesson, we'll talk about the law of sines, whereas in section 6.3, we'll talk about the law of cosines. If I have either of these two cases here, angle, side, angle, so angle, side, angle, or side, angle, angle, then I can use the law of sines. Otherwise, if I have two sides and an angle opposite of one of them, then some people refer to this as the ask case, because this is where the ambiguous case lies. The ambiguous case basically says that we can either have 0 triangles, 1 triangle, or 2 triangles given the information that we are provided. The cases that are solved with the law of cosine are here, and basically 3 sides are given, or side angle side is given. And again, this is what we will talk about in the next section. So the first thing we will talk about is the law of sines and basically what the law consists of and how to use it. So basically, I want to remind you that a triangle will be labeled in this way, where side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. And basically, we set up a ratio. So angle to the corresponding side. And either of these formulas will suffice. I think I typically use this one. But in order to use the law of sines, you have to have one complete ratio. And what I mean by one complete ratio is an angle and the side opposite of it. So that means you need to know either angle A and side A, or angle B and side B, or angle C and side C. And if you know that information, then you can proceed with the law of sines. Okay, so remember that if we want to solve a triangle, we need to find the missing pieces. So in this example, we need to find side A, angle C, and side C. So the first step that I would recommend would be to find the missing angle. And the reason for that is because it's pretty straightforward. Angle C, the sum of the angles still adds to be 180. So we'll take 180 degrees minus 48 degrees minus 105 degrees. And this will give me the measure of angle C to be 27 degrees. Okay, so this one is done. So we know that this is 27 degrees. We just found this. So now we want to find either A or C. So in this case, what I'm going to do is I'm going to use angle A. Now, or find side A. Now, before I proceed, I highly encourage you when solving a triangle, try to use the given information, okay? Try not to use information that you have calculated, like angle C, for example, just in case it's wrong. Now, there will be occasions where we will have to use the information we found, but to be safe, we'll try not to. So applying the law of sines, I know angle B in the side opposite of it, so I'm going to apply the law of sines here by setting up this ratio. And then if I want to find side A, I'm going to set this equal to sine of 48 degrees over A. Then to solve this, I will cross multiply. So A times sine of 105 degrees is equal to 27 times sine of 48 degrees. Then I'll divide by sine of 105 degrees. Oops. And plug this into my calculator. Now, make sure that you try this on your calculator. So pause the video and see if you can find A to be approximately 20.773. Then, continuing, so we found this to be 20.773. We found C to be 27 degrees. Now we only need to find side C. Now this is an example of when we will have to use something that's given to us, or I'm sorry, something that we have found, but I'm going to still use the given information for my first ratio. So sine of 105 degrees over 27 is equal to sine of 27 degrees over C. And then, like the previous slide, we will cross multiply. So I get C times sine of 105 degrees is equal to 27 times sine of 27 degrees. Then divide both sides by sine of 105 degrees. And C is approximately 12.69. Now, you may have noticed up here it says choose another set of ratios to solve, preferably one with no rounded values. That's kind of implying that using angle C rather than angle A, or because side A is rounded. So it might be helpful to try not to use rounded values, because in your work, if you are using rounded values, the next result could be inaccurate because of the rounding. Let's try this example. I think it's helpful to sketch a little picture. So A, B, C. So angle B is 70 degrees, C is 48 degrees, and side B is 15 centimeters. So in order to solve this, we need to find side A, side C, and angle A. Angle A is probably the easiest to find because I can take 180, subtract 70 and 48 degrees to get 62 degrees. Okay, now I'm going to use the ratio with B, and I'm going to find side C. So sine of 70 degrees over 15 is equal to sine of 48 degrees over C. When I cross multiply, I'll find that C is equal to 15 sine of 48 degrees over sine of 70 degrees. Plugging this into my calculator, I should get approximately 11.9 centimeters. The only other thing I need to find is A, side A, and I will have to use the information that I found for angle A. So I'm still going to use this given information involving B, but then I'm going to have sine of angle A, which is 62 degrees over A. When I cross multiply, A is equal to 15 sine of 62 degrees over sine of 70 degrees. And A is approximately 14.1 centimeters. There you have it. Okay, let's try this one here. Sketching a picture, A, B, and C. We're given angle A is 32 degrees. Angle B is 78 degrees and side C is 57. So we need to find side A, side B, and angle C. Angle C is straightforward. 180 minus 78 minus 32 gives us 70 degrees for angle C. Now, I am going to, because I have only one side, I have to use the angle that I just found. So you might want to double check that that angle is correct. So applying the law of sines, I have sine of 70 divided by 57 is equal to, I'll go ahead and find A first. So sine of 32 degrees over A. Cross multiplying, I should find that A is equal to 57 sine of 32 degrees over sine of 70 degrees. So A is approximately 32.14 or 32.1. The last thing I need to find is side B, so I'm still going to use the ratio sine of 70 degrees over 57, but now angle B is 78 degrees over B. And I'll cross multiply, so B is equal to 57 sine of 78 degrees all over sine of 70 degrees. Plugging this into your calculator, you should find that B is approximately 59.3. We now get into the ambiguous case of the law of sines. And the way that the book explains the ambiguous case is fine, but I kind of think it's a little bit easier to understand in a different way. So you can review this material if you want, but I want you to remember that the ambiguous case has three possibilities. There will either be no triangle, one triangle, or two triangles, depending on the given information. And the way the book explains it is like this. So basically, if side A might not be long enough to reach here, maybe it is, or in this case, maybe there are two possibilities for side A. All right, so, read through it. It's helpful. Most books explain it this way, but I'm going to explain it this way. All right, so here's an alternative method. Basically, what we want to do, since we're using the law of signs, we're going to set up the problem the exact same way as before. And you are going to end up getting sine of theta equals something. Let's call that something smiley face. Okay. If smiley face is greater than 1, or if smiley face is less than -1, there will be 0 triangles. And the reason for this is because sine inverse, the domain of sine inverse is in between -1 and 1. So smiley face has to be in between -1 and 1. On the other hand, if smiley face is in between -1 and 1, then there are 2 possible triangles. And the 2 possible triangles, there is either one acute or one obtuse. Oops, obtuse. Now, I want to remind you that sine inverse is, when you plug sine inverse, you only get the acute angle out. So you will have to find the obtuse angle, and sometimes this one can be eliminated depending on the given information. If this angle plus the given angle is greater than 180 degrees, then the obtuse triangle can be eliminated. Okay, now I'm going to show you each of these cases. So I will show you an example of when no triangle occurs, when 2 triangles occur, and when, what did I say? When 0 triangles, 1 triangle, or 2 triangles occur. Okay, so I'm going to show you all the examples. Okay, here is the first example. Now, this is just like the previous examples, so don't let the fact that the ambiguous case exists, don't let that freak you out. So the first thing, as previously done, sketch a picture of the triangle. So angle A is 28 degrees, side A is 12, and side B is 38. Now, we still have a pair, so I'm going to set this up, and then given this information, I have to find angle B. I have to. I'm not given any other information to do anything else. So sine of 28 degrees divided by 12 is equal to sine of B divided by 38. Okay, so when I cross multiply, I find that 12 sine of B is equal to 38 sine of 28 degrees, and then I'll divide by 12. So this tells me that sine of B is equal to 38 sine of 28 degrees divided by 12. This will be smiley face. When you plug this into your calculator, you get approximately 1.4866. Since this value is greater than 1, this means there is no triangle here. Okay, it just does not exist. Here's another example. Let's sketch a picture of this triangle. A, B, and C. This is 68. This is 13. And C is 15. Okay, so given this information, I have to use C, and I must find angle B. Okay, so let's set this up. Sine of 68 degrees divided by 15 is equal to sine of B divided by 13. When I cross multiply, sine of B is equal to 13 sine of 68 degrees divided by 15. This is smiley face, which is approximately 0.804. Because this value is in between -1 and 1, this means that there are two possible triangles. And we want to see if there are two possible. So there will either be one triangle or two in this case. Now, in order to proceed, you will take sine inverse of both sides. Okay, and this will give you angle B. And when you do, you get approximately 53.5 because sine inverse, when you find sine inverse, it will always give you the acute angle. But we know that sine is also positive in the second quadrant. So, since that is the case, we need to use angle B kind of as a reference angle and find the angle in quadrant 2 as well. Okay, so I'm going to call this B1. B2 is the obtuse angle, and that's found by taking 180 minus 53.5. And this is approximately 126.5 degrees. Okay, so I have two possible triangles. Now, before I move on, the first thing I want to do is I want to see if angle B2, the obtuse angle here, I want to see if this triangle can be eliminated. I know that this triangle can be eliminated if my two angle measures so far are more than 180 degrees, because I know the sum of the angles must be 180 degrees. So, to find out if angle C2 even exists, A2, I'll take 180 minus 126.5 minus 68. This gives me a negative value. I cannot have a negative angle, so I can eliminate the obtuse triangle. And that means there is only one triangle in this case. I have found the missing side, the missing angle, B. Now I need to find the missing angle A. Just like in the what I just showed, to find angle A, I'll take 180 minus 53.5 minus the given angle of 68 degrees. And I'll find that angle A in this case is 58.5 degrees. So far, these are the solutions. The last thing I need to find is side A, so I must use this angle that I just found. So to find side A, I'll have sine of 68 degrees over 15 is equal to sine of 58.5 degrees divided by A. Now, it would be in your best interest to not round this if possible so that your answer is as accurate as possible. So A is equal to 15 sine of 58.5 degrees over sine of 68 degrees. So A is approximately 13.8. Let's try another example. Okay, we're going to set this up first by making a triangle. I think it's helpful to visualize what's going on here. I'll use B, and then I must find angle A first. So setting this up, I'll have sine of 28 degrees divided by 10 is equal to sine of A divided by 18. Cross multiplying gives me sine of A is equal to 18 sine of 28 degrees divided by 10. This will give you smiley face. When you plug this into your calculator, you get 0.845. This is in between -1 and 1, so this tells us we have two possible triangles. That means I will either have one triangle or two triangles. Typically, when I have this situation, this two possible triangle situation, I split my paper and I say, this work will be for triangle 1 and this work will be for triangle 2. Then I will proceed with what I have written in blue here to find angle A1. And the way I'll do that is by taking sine inverse of both sides. When I do, I get A1 to be 57.7 degrees. Now remember, sine inverse, when you type that into your calculator, it's only going to give you the acute angle. It is up to you to find the obtuse angle, and the way you will find that is by taking 180 degrees minus the reference angle, which is A1. So in this case, 180 minus 57.7 degrees, which is 122.3 degrees. Okay. Now I'm going to stick here with angle triangle 2 because I want to see if this triangle can be eliminated or not. The way I figure that out is I next try to figure out angle C. So C2 is found by taking 180 degrees minus the angle I just found minus the given angle. If this is negative, I can eliminate triangle 2. But if it is positive, which in this case it is, this means that I will in fact have two triangles. So I'm just going to proceed here with triangle 2 and I'm going to finish solving. So to solve this, you are going to have 3 answers for triangle 2, 3 answers for triangle 1. So in triangle 2, the only other thing I need to find is side C. So to find side C, I will take sine of 28 degrees divided by 10 is equal to, I have to use the angle I just found, so sine of 29.7 degrees divided by C. Plugging this into your calculator, you should find that C2, little c2, is 10.6. Okay, I'm going to jump over to triangle 1 and do the same thing. So I know angle A1, now I can find angle C1. The way I do that is take 180 degrees minus angle A1 minus angle B, and I will get 94.3 degrees. Then the only other thing I need to do is find little c, and the way I'll do that is setting up the ratio. So sine of 28 degrees divided by 10 is equal to, now I have to use the angle I just found here. So sine of 94.3 degrees divided by c. Cross multiply, and I can find little c1 to be 21.2. So I have 3 answers for triangle 2 and 3 answers for triangle 1. I have more examples here that I think would be helpful for you to try. So let's try this one real quick. In this one, sketching a picture. This is 49 degrees, 32 and 28. I have to find side B or angle B. So sine of B over 28 is equal to sine of 49 degrees divided by 32. So sine of B is equal to 0.66. This is smiley face, which is in between -1 and 1. So I have 2 possible triangles. So let's see what we can find. Triangle 1 is found by taking sine inverse here. When I do that, I will get the acute angle for angle B. This is approximately 41.3 degrees. I'm going to jump over here right away to find the obtuse angle here. So I'm going to use angle B1 as a reference angle to find the obtuse angle. And I get 138.67 degrees. Well, in this case, if I add this to the current angle, I'll find that those 2 angles alone add to be more than 180 degrees. So I couldn't even find a third angle, so I can eliminate this triangle. I can go on to find the missing angle for the first triangle then. So 180 minus the given angle minus the angle we just found for B1, and find that C is approximately 89.7 degrees. And then finally, I need to find side C, and I'll do that by taking sine of 49 degrees divided by 32 is equal to sine of 89.7 divided by C, cross multiply, and little c is 42.4. There's the answer. Here, drawing a triangle. This is 31 degrees, this is 3, and this is 6.2. when you set this up, you have to use this information and you must find angle A. So sine of 31 degrees divided by 3 is equal to sine of A divided by 6.2. When you cross multiply, sine of A is approximately 1.06. This is smiley face. Smiley face is greater than 1, which tells us there are no triangles in this case. Done. That's easy peasy. I'd like you to pause this and see if you can solve this. Okay, first things first, draw a triangle. You have to set up a ratio using information from A to B. So sine of 40 degrees over 22 is equal to sine of B divided by 25. Cross multiplying tells us that sine of B is approximately 0.73. This is smiley face, which is in between 1 and -1. This tells us that there are two possible triangles. So, because there are two possible triangles, what I'm going to do is I'm going to split my paper and find out information about triangle 1 and triangle 2. First, I'll take sine inverse of both sides, and this will give me angle B1. Angle B1 is 46.9 degrees. From here, I want to jump right away and find angle B2, because if this angle is too big, given this 40-degree angle, then I can go ahead and eliminate triangle 2. So B2 is going to be found by taking 180 degrees minus the reference angle that we just found. And B2 is approximately 133.1 degrees. Well, if I am able to find angle C2, then two triangles exist. So I know the sum of the three angles has to be 180, so I'll subtract out angle B2, which we just found, and angle A, which is given, and this is 6.9 degrees. Since that is positive, then we can proceed, and there are two triangles. So the only other thing I need to find is little c2 over here in triangle 2. So sine of 40 degrees divided by 22 is equal to, now I have to use the value that I just found for C. So sine of 6.9 degrees, you might want to use the exact value rather than the approximated value. And you'll find that side C1 is approximately 4.1. Now we're going to jump back to triangle 1 and finish solving this. First, I'm going to find angle C1. So 180 minus what we found to be angle B1 minus the given angle. So angle C in this case is 93.1 degrees. And then finally, I'm going to find little side C in this case here. So I have to use the angle I just found. So sine of 40 degrees divided by 22 is equal to sine of 93.1 degrees divided by little c, which is what I'm about to find. Plugging this into my calculator by cross multiplying, I will get 34.2. Okay. Because we don't have a right triangle, finding the area becomes a little more difficult. So we will have to use this formula here. So in order to find the area, we will use one of these formulas. It may appear to be daunting, but it is all, it's just the same pattern. So let's see it in action. So if you want to sketch a picture, you can, but applying the formula, the area is going to be half of the product of the given sides times sine of the given angle. And when you plug this into your calculator, you will get approximately 114.8. Since we are finding the area, the label will be square feet. That's it, nothing crazy here. Here, if you try this one on your own, you should find the area is equal to 1/2 times 12 times 6 times sine of 76 degrees, which is 34.9 square meters. Okay, so here, of course, we are going to have some application problems, so pause this and read through it real quick. Given this information, I know that this angle here is 39 degrees and this angle is 20 degrees. So what I want to do is I want to find the distance from each location to the helicopter. So what I want to do is find A and B. Okay, so I have no choice. I have to find this angle, which we're going to call C, because I have that opposite side. So C is going to be 180 minus the two given angle measures. So angle C is 121 degrees. So I have to use this and the law of sines to find the missing sides. So sine of 121 degrees divided by 200 is equal to sine of 20 degrees divided by B. Plug this into your calculator and you should find that B is approximately 80 feet. Do the same thing to find side A using the ratio sine of 121 divided by 200 is equal to sine of 39 degrees divided by A. Cross multiply and you will find A is approximately 147 feet. Okay, take a moment and read through this problem here. Okay, so we want to sketch a picture, and if we want to estimate the height of a building, this is kind of nice because there will be a right triangle. So sketching a picture of this here is the height to the building. I'm going to call it H. We have two different measurements. First, we have the angle of elevation here. But then there's a second measurement that is taken 100 feet closer to the base, which means this distance here is 100, and this angle measure is 78 degrees. And we want to estimate the height to the building. Well, what I can do is I can find, I'm going to call this X. If I find X, then I can use SOHCAHTOA to solve the right triangle. But in order to do that, the first thing I need to do is find angle star so that I can find side X. Angle star is can be found by taking 180 minus 78 degrees since they're supplementary, and I'll find that angle star is 102 degrees. So with this given information, if if I know angle star, I can find angle smiley face. Angle smiley face is found by taking 180 minus the other two angles, which was 102, which we just found, minus 43 degrees, which gives me 35 degrees for angle smiley face. So now I have enough information to find x. And the way I'll do that is by using the law of sines. So sine of 35 degrees over 100, because that's the only given length I have, is equal to sine of 43 degrees divided by x. And remember, I need to find x in order to solve that right triangle. Cross multiplying finds that x is approximately 119 feet. So now I can solve this right triangle because this is 119, this is 78 degrees, and I can find h. SOHCAHTOA tells me that sine of 78 degrees is equal to h over 119. Multiply both sides by 119, and h is approximately 116 feet. So the approximate height of the building is 116 feet. This problem is solved the exact same way as the previous problem. The only difference is that we have to take into consideration eye level. So I'm going to set this up a very similar way. So this will represent the height of the water in a fountain. So let's see, this angle of elevation here is 25 degrees. And then the person goes 30 feet further, so this is 30, and the angle of elevation is 18 degrees. So I'll solve this the same way as before. So I'm going to call this x and this y. And the thing we'll have to consider is that this is eye level, so it won't be the full height of the water. So once I find h, I need to add 5.5 to get the final answer. Okay, so like the previous problem, I should find that this is 155 degrees because they're supplementary angles. In this leftmost triangle here, the sum of the angles need to be 180, so this is 7 degrees. So the law of sine says sine of 7 degrees divided by 30 is equal to sine of 18 degrees divided by y. And I find that y is approximately 76.1. Now I can use SOHCAHTOA for this right triangle. And SOHCAHTOA says that sine of 25 degrees is equal to h divided by 76.1. So h is approximately 32.15. Well, that's just this height. I need to add the eye level of the student, which is 5.5. So this will give me the height of the water in the fountain to be approximately 37.6 feet. And that concludes this lesson.